So in terms of actuators, there are lots of terminology that is involved. Some of them are thrust or power, how fast the accelerator is, what is the correction speed, what is the acceleration, stroke length, mounting, what type of coupling we have, and things like that. Actuators are pretty standard right now. It's not as important as installation of a waveguide or the sensor, but it is an important part of a web guiding system. The older actuators were either pneumatic or hydraulic. You had a hydraulic pump pumping a double acting cylinder and moving the web guide structure. These were more common in the 50s and up to about maybe 90s, before the electromechanical actuators started coming into the market. You could have pneumatic actuators or hydraulic actuators. The hydraulic actuators have the advantage that it can provide high thrust and can shift large loads quickly. Even now in metals industry, hydraulic actuators are pretty common. You can see them. But the problems are that it's a problem with maintenance. You need to balance the valves and stuff like that, change the filters, they could cause leak, and this could contaminate your product. And then the precision and accuracy that you can get with an electronic actuator or electric actuator is not something that you can expect in a hydraulic actuator. So most web guides nowadays are going to use actuators. Like what these actuators usually have a motor that drives a belt pulley system. There's usually a lead screw, a ball screw, or a roller screw that converts the rotary motion into linear motion at the end of the actuator. Some common terminologies that you would see with actuators are maximum current, voltage, power. Whenever we have something with a lead screw or a pitch, that's a common term. What is the lead of the actuator, pitch of the actuator, gearing ratio. Backlash is another thing that you would commonly see with electric actuators, especially with low-end lead screw actuators. Resolution, what is the smallest movement an actuator can produce. Backdrive is a common terminology, especially if you're installing a web guide that has to work against gravity. And then types of actuators, you have inline and reverse parallel. Some actuators have limit switches or end stops. And then type of motor used in the actuator, you would commonly see servo stepper, brushed or brushless DC motor. So actuators are providing the driving force to the guide structure so that it can position the web. In terms of thrust, the thrust is the amount of force exerted by the actuator to move the guide structure. And this thrust really depends upon, as we saw before, mass of the structure that we are trying to move, what is the friction there, how fast you want to move, and sometimes gravity as well, if you're acting against gravity. In terms of sizing actuators, these are some of the things you need to know to size an actuator properly. Web line speed, mainly because if you have a slow moving web, the maximum disturbance frequency you can get depends upon the speed of transport of the web. If you're moving at 100 feet per minute, you might not need a high dynamic response, while if you're moving at high speed, you might need a much higher dynamic response. The dynamic response is related to the acceleration is related to the thrust. So that's why line speed becomes important. Guide structure weight and roll weight. If you're trying to move a big mass, we need to know that. What type of bearing you're using, so that what is the breakaway force that we need to overcome based on the coefficient of friction of the bearing. And then what kind of disturbances we are trying to correct for. There is a correlation between the amount of disturbance that can propagate through a roll-to-roll machine. That really depends upon the speed of the web. The faster you go, higher frequency disturbances can go through. So the web acts as like a low-pass filter. And then the acceleration. And then if you have to look at any gravitational effects. These are some of the key factors that are involved in properly sizing an actuator. But like I said, actuators are pretty straightforward nowadays. You just need to have some basic questions answered, and then we'll be good to go.